Okay, good morning.
Good morning.
As we stand on every promise of your word, that's a very fitting song. I don't know if that was by design or not, but that's kind of the essence of what this whole series has been about. Is God's account of creation true? Is His word trustworthy? So we're picking up again today here, moving on to old earth and the evidence. In a way, this is kind of the hardest topic. Because this is the evidence that, seems to contradict God's word, and there is some. But it's not as strong or as formidable as you may view it. But we're going to look at it and be as honest, straightforward as can, where it's strong, where it's not, at least in my opinion. So, just a quick rehash of last week. Global flood, we looked at it, and even though it's dismissed by popular culture and the science today as a myth, there's actually very compelling evidence the flood really happened. That it was global, that it was unbelievably catastrophic. The major evidence for it is the massive sedimentary layers that span continents, thousands of feet deep. What could lay down all those layers except a global flood? The idea that is river deltas or big lakes just is beyond ludicrous. So also the fossils the testimony of the fossils is sudden, rapid burial, traumatic death, nearly instantaneously across the world, hundreds of millions of fossils, and fossils are no longer made today. So the testimony of the sediment and the fossils is of a global flood. We also kind of looked at a possible method that was in his book, but basically because of the catastrophe of the globe changing, there are plausible scenarios that explain things why the Earth may have rotated on its axis and why we have tropical vegetation frozen down in Antarctic. Explain why mountains were uplifted all recently, all at the same time. Ocean floor drops, canyon formation, ice age, number of major geological features, all the best explanation is a global flood. So now we're going to look, is the Earth young? Whoa, what just happened? Is it on there?
No.
The screen timed out somehow. Okay. Yep. Okay, so is it young or is it old? And, this contrast between a baby and an old man doesn't do justice for the difference that we're really talking about. So here's the old Earth version. Earth formed 4.6 billion years ago. First life about 3.9 billion years ago. And here we go. These are billions of years. So to give you an idea, here's the last 500 million years over here. So we're going to expand those. Okay, so around 500 million years ago is when we find the layer where all the fossils start. And it's amazing because all these fully formed, hundreds of perfectly formed species, very intricate, exploded into the scene. So they call it the Cambrian explosion, and they interpret that as that's when life really took off. So much for gradual, though. It's all there, fully formed, all at once. So we can go on down. The dinosaurs, 250 million, down to about 60 million BC. Then some sort of extinction event. And then how do we know the dinosaurs lived in this area? Anybody know? So they're buried in sediments, so as we're going to find out later, in sedimentary rock you can't tell the age, but because they're in a certain layer, we interpret that layer as being really old because there's other layers on top. So because they're consistently in these layers, we say, well, those layers are 250 million, 100 million, 60 million. So,
We don't say
that when I say we, the common, scientific community. So now we're going to unpack that last 50 million years. And dinosaurs were dead, so mammals sort of thrive. And eventually, one particular monkey, becomes a hominid, starts walking more on two legs, And so now we're going to unpack the last 5 million years. And somewhere, we don't know, between 1 and 5 million years ago, Homo sapiens finally came around onto the scene. And Joe, just to finish things out, so there, that little line is the last 10,000 years. So it gives you an idea of the magnitude of the difference that we're talking about. And for most people, they laugh at this idea. And after you spend some time looking at it, though, you kind of laugh at this idea. Deep time, like they propose here, has some huge problems. And we're going to look in those with our next lesson. But anyway, we're going to go on. So just a reminder, determining the age of something is historic science. I talked about that once before. It's not operational science. You can't repeat it. You can't do it over and over again. You can't show the force of gravity or force equals mass times acceleration. We look at some data, we interpret it, and then that's it. The data doesn't speak. It's how we interpret it. And so mostly it's involved, we find things that seem to be constant today, and we can extrapolate that process backwards. So we say, hey, here's a clock that seems pretty regular and consistent. We're going to extrapolate that back. And so we're going to look at some of those clocks. Okay, so here's the major lines of evidence. There's 8 things here. I've grouped a few of them because they're very similar. And we're going to go through these as quickly as I can. All right, so geology and fossils. So we talked about that a lot last week, but geology is held up as one of the main evidences of an old Earth. And so, because folks will point at all those layers being laid down in a delta. And you and I know, after having looked at it, that kind of sediment, look at that. Thousands of feet, as far back as you can see on the horizon, on beyond the end of the continents, the testimony of the layers is of rapid global deposition. Lakes and deltas don't make that. Okay, the answer to this question is it's a lot of water and a little time. Fossils, we just talked about that before again too, but sudden traumatic burial, so that buried while eating a fish, buried while giving birth, lots of them all swept together. This is not the scenario of some wounded creature laying down in a swamp and getting buried. And we know that when wounded creatures lay down in swamps, they get eaten and decompose. They don't leave fossils. So the testimony of the fossils, even though it's held up as old Earth, interpreted hundreds of millions of years, the actual testimony of the fossils is it all happened all at once, and according to the Bible, very recently. So we're going to move on to dinosaurs. So dinosaurs, I grew up reading books and books about dinosaurs, and dinosaurs are millions of years old, right? 250 million years, 150 million years, the Jurassic period, the Cretaceous period, Tyrannosaurus, and my favorite was Allosaurus, and I was bummed to find out that there's no longer Allosaurus. It's been reclassified. But and I had that cognitive dissonance growing up. I accepted dinosaurs were millions and millions of years old, and then I would read the Bible, and I just wouldn't reconcile those two. But are they really millions of years old? And how do we know they're old? Mainly because they're buried in layers deep, and we interpret deep layers as millions of years. That's it. There is no other, and you're going to learn something in this, that actually a lot of things that point to they're young. So consider Job chapter 40. So behold Behemoth. This is God speaking to Job in their debate. Which I made as I made you. Behold, his strength is in his loins. He makes his tail stiff like a cedar. His bones are tubes of bronze, his limbs like bars of irons. He is the first of the works of God. Under the lotus plant, he lies in the shelter of the reeds and in the marsh. What could that be? Maybe that. So people who don't believe dinosaurs existed in recent history will say, oh no, that's an elephant or a hippopotamus that's being described. But tail stiff like a cedar? You all seen a hippopotamus or an elephant tail? Kind of little tiny little thing, hardly worth having. So the next chapter in Job, can you draw out Leviathan with a fishhook or press his tongue down with a cord? Who can open the doors of his face? Around his teeth is terror. His back is made of rows of shields, shut up closely as with a seal. Out of his mouth go flaming torches. Sparks of fire leap forth. His breath kindles coals, and a flame comes forth from his mouth. Though the sword reaches him, it does not avail, nor the spear, dart, or the javelin. He counts iron as straw and bronze as rotten wood. His underparts are like sharp potsherds. He makes the deep boil like a pot, and he makes the sea like a pot of ointment. On earth there is not his like, a creature without fear. Sounds to me like a dragon. I don't know. It's a little interesting. Is this land-based or sea-based, stirring up the sea and with a fishhook? That's a mosasaur skeleton, about 50, 60 feet long. I don't know. We also, all cultures have legends of dragons. This is written as if, the sword and the spear are encountering this. This is written as if contemporary. In Job's day, people knew exactly what Leviathan was, and it wasn't something to be tangled with lightly. And God's saying, I made that. Who are you? You don't dare mess with that. I made it. How did these ancient cultures know to draw these? The Anasazi Indians in Utah. This is estimated between 800 and 2,000 years ago. How do they know about that? Long before we found the fossils 150 years ago, over in Cambodia, 800-year-old temple, is this carved in. And this is just few of scores of pictures of dinosaurs, and then there's the dragons, which are everywhere. So there's a lot of evidence that people coexisted with dinosaurs. So they existed before the flood, baby dinosaurs were on the ark, and they existed after the flood, and they have since gone extinct. That is a reasonable interpretation of the evidence. So the evidence that dinosaurs are millions of years old is just a story. Finally, 10 years ago, an evolutionist archaeologist decided to cut open a Tyrannosaurus thigh bone and look inside, and inside she found what looks like blood vessels for bone and marrow, red blood cells with nuclei, endothelial cells, which are the cells that line blood vessels, and collagen proteins. Okay, now mind you, this is supposed to be 200 million years old. Organic matter doesn't survive. Mostly they would say it doesn't survive 100 years. Definitely, not 1,000 years, definitely not 1,000,000 years, really not 200 million years. That is beyond preposterous. And yet here it is. So if it was perfectly, rapidly, instantly buried about 4,000 years ago, maybe there might still be some there. That's what this seems to suggest. But the fact is 200 million years ago. So of course evolutionists dismiss it, say, well, it was a contaminated sample. After that was proven not to be possible, they said, well, there's some unknown process that allows biologic tissue to exist for 200 million years. Gives you an idea of the mindset that is out there. Okay, tree rings, ice cores, and varves. These are the clock kind of things. So we all are familiar with tree rings. You can count in, and each one of these rings represents a year. During the precipitation season, it grows a lot, and then the dry season, it gets dark. Year by year, you can count. So you can also string together trees, and if you look and see like, well, gee, that pattern there matches that pattern from that tree, and that precedes. So you can start to sequence trees, and you can start to try to get a chronological clock. Of course, all this assumes that 1 year per ring. Is that true or not? Mostly is what we see today, but has it always been that? Could a wet season followed by a dry season followed by a wet season followed by a dry season in 1 year happen? There's some evidence that that could happen in recent history. Could it have happened more in the era following the flood? We don't know. But the oldest tree that is still alive today are the bristlecone pines up on the White Mountains that straddle the border between California and Nevada. So those are all, they date them at 4,800 to 5,000 years, which is pretty close to the flood. It's a little beyond what we think the flood is, but it's certainly within the range. But it's interesting, that is the oldest living thing on the planet, are those trees. Why was there not plants older than that, necessarily? So that sort of points to a young Earth. However, they have taken some of these trees and sequenced them with some dead ones there. And so the scientists, the longest sequence that they've been able to string together, did they overlay them right? Did they interpret it right? Is almost 14,000 years. And those trees aren't right next to each other. It's a tree here, and then there's a tree 100 miles down on another mountaintop, and they look at the rings and say, gosh, these rings kind of overlap those, and they make these sequences. So they're pretty rigorous about it. So that's a piece of evidence that suggests that maybe the Earth isn't as young as we think, but it's just interpretation of the evidence. Similarly, ice cores. We've gone up to Greenland, we've gone down to Antarctica, and we drill ice cores. We pull the cores out, and we interpret each of those layers as there's a winter season where everything freezes, and then there's a summer thawing season, and it creates these different layers. So we just start counting the layers, and we go back, and there's a lot of layers when they pull these out. So in Greenland, they say they counted over 120,000 layers. In Antarctic, even more, 340 to 740,000 layers. So again, is that clock right? Is it one set of pair per year? Could there be multiple sets? Could the climate create multiple in a time? Also, I understand that as I get to the really deep layers, there really is no more layers. It's a lot more subjective in interpreting them, the stuff that's been compressed down there. But that's a piece of evidence that says maybe the Earth is old. And finally, varves. Varves is kind of the same idea as ice cores, but it's with mud. And so here you can go to a lake bed and you can drill out the mud and you can look at these layers, and then they look in the layers and they find pollens. And there's pollens that they associate with spring, and then there's pollens associated with summer, and then pollens associated with the fall and winter, and then the cycle starts again. So you start counting all those layers, you can say each one of these sets represents a year. Seems pretty plausible, and they count them, and in Switzerland and Sweden, they've come up with these numbers, 7,300 and 9,500 years. So, again, it seems pretty compelling, but it's the evidence is silent. It's our interpretation of it. But that's something that people will point to that says the Earth is old. Similarly, you have, without the organic lakes, you've got times where you've got all these layers. The Green River Shale, 2,000 feet of layers. Mind you, what does that scream? A big giant flood, rapid deposition. It's got over 6 million microlayers. So again, their scenario is that's 2,000 feet of a river delta? How does that work? How does the river delta go up that much? But they interpret it because there is difference between these two layers of summer and winter. Some of them are 1/10 of a millimeter thick, which just doesn't, it doesn't make, what makes sense is all laid down at once and some sort of sorting mechanism that created these layers, but not that it's 6 million years old, 6 million layers. But that's evidence, that's the VARV evidence that points to an old Earth. Okay, radiometric dating. I'm going to get a little bit into the science here. So there's radiometric dating for volcanic rocks and radiometric dating for organic objects. Two completely different things. So we're going to look at the volcanic rocks first. Now, mind you, is sedimentary layers, limestone, sandstone, is that volcanic? No. So this doesn't date the sediments, and guess what all the fossils are found in? Sediments. So the fossils can't be dated by the sediments can't be dated by the fossils, but that's what they do. They say, all the dinosaur bones are here at this layer, so we know this layer is that old. And you say, well, how do you know that layer is that old? Well, that's because those dinosaur bones are there. It really is this circular logic. That is it. That is all their evidence they have. However, so they go to volcanic rocks, and this is the principle that these different uranium, potassium, rubidium are radioactive, they're unstable. And so here's the explanation of what goes on. So the lava is liquid, and then it cools, and it has embedded in it, let's say, some potassium that's unstable. So it solidifies with that potassium in there, and over time that potassium will decay into its daughter product. It goes from being, the parent is potassium, it decays, and it becomes argon. And so the argon, initially, it's a gas. And this is liquid lava. The gas escapes, so it's empty. And so over time, the potassium decays, and the daughter, argon, fills up. So we come along, and we look, and we measure that, and we say, gosh, there's that much argon in this sample. We know how fast potassium turns into argon, which is very slowly. And so therefore, we can figure out how much time that piece of lava has been there. It's pretty plausible, but the assumptions in that are, has the decay rate always been what it is today? And we have some, we've tried to change the decay rate, and temperature and pressure doesn't really change it. Seems pretty constant, so that's a reasonable assumption, but it's not for sure. Could conditions in the past have changed the decay rate? Was there nothing in there to begin with? Well, it was a gas, so we don't think it would stay in there, but could some have been in there initially? Maybe. And did anything infiltrate it from some other source along the way? Did any argon come up from below? So those are all assumptions that they make. But using this method, they come up with, this is one of the deep time measurements. Okay, so this is how they come and say that this rock is 2 billion years old. It's the radioactive measurements, or radiometric dating, is where the billions of years come from. So when they say these are the oldest rocks on the planet, 4 billion years, they used one of these methods because it decays very slowly. So here's some problems with it, though. First of all, data scatter. What isn't advertised is they'll give a sample of lava to someone who will do the analysis, and they come up with a wide range of numbers. Okay, so here's some of the more extreme ones, but the one sample from New Zealand came up with 270,000 years to 3.9 billion years. Okay, that's not very precise. And so what happens when they give these spans is the geologist will pick the one that he thinks fits best with where that rock was. And if the number they come with doesn't make sense, he says, well, give me another one. So there is a whole lot of inaccuracy in this. Look at that. In the Grand Canyon, lava layers ranging from 1 million to 1,000 million years. Not very precise. Clearly something's going on that we don't know. And then this Allende meteorite has a 6 billion year range of uncertainty. Okay, so clearly something's going on in this process that we don't understand, and not a lot of credibility put on it. Furthermore, some creationists sent in some samples of lava from known lava flows. Like in Hawaii, we know that lava flowed 200 years ago. They sent it in, and the answer came back, oh, that's 22.8 million years old. Okay, so we know the process doesn't work. So the radiometric dating is, in my opinion, unreliable. They have made some assumptions that seem plausible, but there is a whole lot of evidence that it's bunk. Furthermore, that guy Walt Brown that I mentioned last week, in his newest 9th edition, he has laid out a whole chapter that I just read in this last week. I have the 8th edition. But his chapter, he lays out a process. He says, hey, look, we don't even really know where radioactive material came from. There's not a whole lot of it out there in the rest of the universe. It's only here on Earth. And he says, so maybe it was formed here on Earth, and maybe it was formed during the flood. And he came up with a series of plausible scenarios whereby the convulsions of the Earth could have created the energies necessary to make the radioactive materials. And if that's true, when it did that, he also says along the way, it would have left a whole lot of these daughter products in those places too. So I don't know if, it seems a little bit of, boy, just right for things for it to happen, but the evolutionists don't have a good explanation of where radioactive material came from either. and it's mostly here just on Earth. So, carbon-14 dating. This is the organic stuff, the living stuff. And very quickly, basically the sun turns some of the carbon or the nitrogen that's in our atmosphere, it turns it into a radioactive form of carbon called carbon-14. Very, very small percentage, but that carbon-14 becomes carbon dioxide, and the carbon called carbon-14. Most carbon is carbon-12, but it makes a little bit of carbon-14. Carbon-14 gets breathed in by all plants, and then all animals eat those plants, or we eat the animals who eat the plants. But basically every living thing ends up with this micro bit of carbon-14 in them. And everybody gets to this level of equilibrium as long as they're alive. Some's coming in, some's going out, and you hit this level of equilibrium. And we know what that level of equilibrium is. So when that thing dies, though, it's not bringing in any more carbon-14. And so the carbon-14 starts to go down. And so it's like this clock starts ticking when something dies. And so we know how fast carbon-14 goes away, so half of it goes away in 5,700 years. And so, if you know the starting point right here, and you measure this much, you know that thing died 5,700 years ago. That's the idea behind carbon-14. And they've gotten a lot better at it. It's gotten a lot more, this is just showing the picture again. Something's living, as soon as it dies, it's the same, and then the carbon-14 starts going down. And this shows that after about 5 periods of that 5,000, so 28,000 years, basically 30,000 years, no more carbon-14, it's all gone. So we can only use carbon-14 to date things back to about 30,000 years. So they've dated a lot of things that are 10 to 40,000 years. They say it's this old. So, problems with that. Number one, if the Earth was really old, the ratio of carbon-14 to carbon-12 should have stabilized. It's not. It's still climbing. It implies the Earth isn't very old. Number two, environmental factors can change that ratio as the amount of carbon dioxide in the air changes. And we think that maybe before the flood, that carbon-14 ratio was much lower than it was today. So when we count a really low amount of carbon-14 now, is it because it's decayed away or because it just didn't start very high? So anyway, and the last thing I'll say about carbon-14 is it presents some real problems for old Earth too. And so I'd like to talk about those, for example. So coal, here's a coal seam. Coal is, according to standard evolution version, it's vegetation that's laid down, and then over hundreds of millions of years, heat and pressure turn it into coal. So it's hundreds of millions of years old, so would it have any carbon-14 in it? No, more than 30,000 years, 0. Okay, well, some creationists said, we think that was made by the flood. So they took some coal samples, sent them off to be carbon-14 tested, and lo and behold, they all still had carbon-14, said 25,000 years. That doesn't quite fit the 4,000 years, but it sure is a whole lot closer to the short Earth than the hundreds of millions of years. Fossils. If 250 million year old fossils, should they have any carbon-14? Of course not. All of them do. Evolution's never even sent them in because they knew it didn't. So fossils have carbon-14. Even diamonds, the oldest things on Earth, carbon-14 when they sent them in. So carbon-14 suggests that the things that we said are hundreds or billions of years old, hundreds of millions or billions of years old, are actually relatively new. Finally, starlight. The basic idea of starlight is light travels really fast, 186,000 miles per second. And so the time that it will travel in a year is about 6 trillion miles, a long distance. But the things in space are even further away. Okay, so the moon is 1 light second away. The sun is 8 light minutes away. The nearest star is 4.3 light years away. So it takes light from that star 4 years to get to Earth. Our galaxy is measured as 52,000 light years. So it takes light 52,000 years to get from one side of the galaxy to the other. And it goes on. We see stars and galaxies that are millions of light years away. So, how can light from those stars reach us if the universe is young? So if it's 100 million light years away, that light reaching us, under common understanding, is 100 million years ago. So that's a very compelling evidence for deep time on it straightforward. So what are some explanations? Well, number one, God created the light in transit. And it just like he created Adam and Eve as full-grown adults, full-grown trees, there's appearance of age. He made the stars and he created the light in transit. It creates a little bit of a problem though, because like when a star blows up, we see a star blowing up, and if it's only 6,000 years old, he created this. It's actually 100 million light years away, or so the understanding is, but we see it blow up 100 years ago. It's like he made this image of this star blowing up, but the star never actually existed. It kind of crazy that. So there just a lot of people have a problem with that option, but could be. There's some evidence that the speed of light is decaying, getting slower, and in the past it was faster. Current evidence is maybe at 1 or 2% faster, but there's some evidence that it was decreasing faster farther back. That could be an answer. And the third one is the Bible is full of God saying, I stretched out the heavens, I stretched out the heavens, I stretched out the heavens, etc., 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 stretched out the heavens. This is the idea. At the beginning, Earth and the stars and the light in between close together, and then when he stretched it out, there is this relationship we figured out between time and space, and that time and space, as you change them, the others change too. So basically the idea is a time dilation could happen as God stretched out the heavens and made all the space. It's kind of esoteric stuff, gets into the theory, a special theory of relativity, but there is definitely the relationship of time and space has been well established and documented. So that seems to me is the most plausible one. So last thing before we wrap up, evolutionists have the same problem. As they look at the universe and they say, gosh, this side of the universe is a billion years apart from the billion light years apart from the other side of the universe, yet they're all the same temperature. They needed to be exchanging light and energy because they're all at the same temperature, but they're too far apart. There's not enough time for the universe to be as uniformly cooled because the energy just couldn't move around. So they essentially have the same problem, that something about the speed of light and the size of the universe just doesn't work for anybody. So here we go. Conclusion. Geology and fossils are better explained by the flood, not eons of time. Dinosaurs, evidence suggests that they're actually contemporary with humans. The rings, cores, and varves, evidence I'd say favors 10 to 15,000 years, but there are plausible error sources. Radiometric dating, it supports deep time, but there's huge data scatter, and known error, and not persuasive. The radiometric dating, there's evidence that favors things are 10 to 50,000 years old, but there are plausible error sources, and it destroys many deep time beliefs. And then finally, starlight seems to support deep time, but space-time dilation or stretching is a plausible alternative. So all of these, we just got to step back from that and remember, these are forensic interpretations of silent data. And they're made by sinful men, many of whom have an agenda for the earth to be old and there to be no God. And in the past, dinosaur fossils, canyon formation, and petrified trees have persuaded those contemporaries to abandon God's truth because that evidence seemed overwhelming to them. But each of those problems has been debunked over time. So of these that exist today, which of these, are you not sure about and will I'm confident that they will be debunked over time. So that's the quick,
Like Specimen Ridge.
like the petrified trees was that story I told of Specimen Ridge with the forests, petrified forests on top of each other, and there is an actual explanation for that. Okay, so there was a wave top survey of the old Earth evidence. Next week, my wife and I will be at a wedding, so we won't have this. We'll have some substitute thing. The week after that is the family camp, so we will pick up the week after that with young Earth evidence, and then finally a wrap-up the following week. So 2 more weeks, and we'll be done. So this was very science-heavy today, but I wanted to give you, this is some of the stuff that's out there for old Earth. It's not all just make-believe. There is some solid evidence that the Earth appears somewhat older than the Bible would have it, but it's not enough to give away your faith. Thank you. Let me pray. Lord, thank you for giving us your word. Thank you for giving us enough evidence to know that it's trustworthy. Thank you for creating a world that is so real and so wild and so magnificent. You have made us, and you have made life in a way that it is not like just a storybook. There's something about it that is so far beyond that and so much richer and so much deeper. We thank you for that, Lord. Now we lift up this day and this chance to worship you corporately in your Son's name. Amen.